Morning to all present here. I am Satish Kumar, working as assistant professor at Department of Electronics and Communication Engineering at K.S. Rangasamy College of Technology. Today we will discuss a topic on n-element linear array and n-pair array. So first we see what is antenna array. So antenna array is a single system which forms arranging various antennas in an appropriate manner. An antenna array is a set of two or more antennas. So basically it has a proper spacing and proper phase with each other. Whenever antenna transmits a signal to a long distance, it is necessary to possess a high directive gain. So by using an antenna arrays, we can provide an high directive gain. So antenna array is a group of individual antennas that works together as a single unit to transmit and receive the radio waves. So it creates more complex and directive radiation patterns, and we can control the phase and magnitude of signals using these antenna arrays. And we can focusing the signals at particular directions are used for various applications. So to achieve greater gains, we need to increase the electrical size of an antenna and enlarging the dimension of single elements. So most efficient is to use the array antennas to achieve greater gains. So major task of antenna arrays are increasing overall gains, provide diversity reception, cancel out interference from particular set of directions, determine the direction of arrival of the incoming signals, and to maximize the signal to interference plus noise ratio. So types of array antennas are, basic types are linear array antenna, circular array antenna, planar array and phased array. So in linear array we see n-pair array. So first we see the linear arrays. So linear arrays are antenna elements arranged along a single. So elements of array are uniformly spaced with each other. So linear array is classified in two types, two element array and n element linear array with uniform amplitude and spacing. So two element antenna array consists of two antennas positioned at specific distance and with a controlled phase difference. So only we are using two antennas which is a specific equal distance between the two antennas. This arrangement allows the manipulation of radiation pattern, and we can control the radiation pattern or we can provide the directional beam forming and useful for antenna characteristics. This is a figure of a two element antenna array which focuses on single point source. So E1 and E2 are the normalized field patterns, where M1 and M2 are the field magnitudes, and R1 R2 is the distance from the observation point P, and beta is the phase difference between the feed of two array elements, and P1 and P2 are the polarization vectors of far field zone. So here we see the electric field En1 and En2. The array elements are identical to each other. Similarly, the polarization are also equal. They are oriented in same way in space of identical polarization, P1 equal to P2. Similarly, the same amplitude, M1 equal to M2. And next we see the n element linear array with uniform amplitude spacing. An array of identical elements with identical magnitudes with progressive phase is called uniform array. Here n element array using n number of elements with uniform spacing at the amplitude as well as phase. So here we are using that electric field, that is n number E1 plus E2 plus E3 up to n number of electric fields with equal spacing of amplitude as well as phase. Next we see the broadside antenna array. So in broadside antenna array we will use arrangement of multiple identical elements that are placed parallel along the line. So normal to the antenna axis forms a broadside antenna array. These elements are present horizontally at equal distances. Each element is fed with a current of same magnitude and phase. Broadside array antenna. In this arrangement, when the elements are excited, the maximum radiation occurs at broadside, while the little amount of radiation is emitted at other side. So in broadside, we see both the major lobe and there is a small side lobes. There is a little amount of radiation is emitted on other directions. They provide a bidirectional radiation on both sides. The reason of bidirection is it radiates both the direction along the broadside. As the end-fire array is a type of antenna which has maximum radiation is focusing on the axis of array. So it is a maximum radiation occurs at the axis of antennas. It lies on the way of excitation at phase shift of 180 degree out of phase. So while in case of broadside, elements is fed with the current of the same phase. So in end-fire array offers a unidirectional radiation where maximum radiation is achieving along the direction of the axis of antenna. So this radiation pattern shows maximum radiation occurs at the axis of antenna. So difference between end-fire array and broadside array with respect to radiation pattern, the maximum radiation at axis of array, where in broadside array maximum radiation is perpendicular to the axis. In directionality, highly directional in end-fire array. In broadside also it is highly directional to the array. And phase difference in end-fire array, adjacent elements have phase difference to ensure constructive interference. So broadside has no phase difference between adjacent elements. So applications are end-fire array uses in radar system, long distance communications, and broadside array applications using ATV broadcasting. And the beam width for end-fire array is narrow beam width along the axis, and beam width for broadside array is wider beam width perpendicular to the axis. So the questions, multiple choice questions has been given. The students can go through the slides and can answer the questions. Thank you.